back. It's been a little while, mostly due to that lurgy that's going around the world, doing a bit of a number on our family. So anyway, we're pretty much on the other side of that now. Today I'm going to rejig a power supply on a Commodore 64. I picked up a 64C quite a while ago now and haven't had a chance to even take it off the shelf and turn it on. But before I do, I'm going to rebuild the innards of the power supply, because Commodore 64 power supplies are notorious for going pop and taking the machine with them. So yeah, I mean, as you can sort of tell, I'm recording the intro after I've already done the done the bulk of the video. But yeah, so anyway, we'll get into it and see how it goes. I've obviously already opened this Commodore 64 power supply because I needed to take some measurements from it to come up with a replacement board. This is the, I assume, the Australian edition of the Commodore 64 power supply. This one came with a Commodore 64C. I'm not sure if all 64Cs came with a supply like this, or whether it was just the Australian ones, but unlike the earlier 64s, this one isn't fully potted. And probably doesn't have the tendency to overheat like the original units did, which of course led to failure. I was going to say premature failure of the voltage regulator, which then in turn fried components in the computer. But it's probably a bit unfair to say premature failure of the voltage regulator, because we're what, 30 odd years on from when these things were designed and produced, and 30 years is not a bad life for something like that. It is a shame though that when they fail, they pass the supply volt, or the transformer's output voltage, through to the computer and cause things to pop though. So anyway, I've designed a new board, and yeah, we'll set about putting that together and see if it works. So my new boards arrived earlier today. Other than taking them out of the box they came in, I haven't opened them yet. So let's see what we got. So 5 of them, of course, because that's the smallest quantity that you can order. And yeah, there we go. So hopefully everything will fit. We'll soon see. Right, put a little bit of solder on one side of the inductor. That should be enough to hold one side down. Hopefully. And we should be able to solder the other side. I think it's alright. As soon as we look under the microscope, you should be able to tell. Must admit, when I was a kid, it never occurred to me that one day I'd be soldering components with tweezers. I guess it was a logical conclusion, but it never occurred to me. take the old power supply and we can remove this heatsink. And what have we got? So our 9 volts AC should be over here. Yep, that's 9 volts AC. And then if we go here, plus 5 volts, and the polarity is correct. So pink is positive. Sweet. So confirm that our colouring is correct. Easier just to snip, 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 and snip. Keep that because we will reuse it. So these are intended to go in here, like that. But we'll, actually, I might have made these a bit close together, to be honest. Might slip some, yeah, that one's going to be a problem getting that in. Only get one. It goes in this, yeah, I can get it in like that. I'll just put some heat shrink on there though. Yeah, since those leads are fairly close together, just in case they decide to rub or anything silly like that and wear through the insulation. Just put a little bit of heat shrink on there. Whether I shrink it's another question, but at least it'll be on there and provide some degree of insulation. And that's a fraction too long. Length. And that one, I should need a slightly bigger bit of heat shrink for the common. There's a bigger piece, but it's too small. As in, it's not long enough. But this bit will be. Right, so put the common in the middle. Soldered. How's this going to go in case? Is this going to work? Like this? Like that. salvage this. Hopefully these holes are big enough for this as well. This is yellow and green, and 9 volts AC, so that's those two. And positive is J6, which I thought I had on the silk screen, but apparently I didn't. And blue is ground, so hopefully I can get these through the holes. If I solder them, I won't be able to. So that's the ground. Quick eyeball, see if we've got any obvious shorts. And we'll have some low resistance because we're across the transformer coils, but I don't think we have any shorts in the board. Turn it on, eh? See if anything goes pop. Well, it's on. So we should be getting 9 volts AC up here. No reason we wouldn't, it's simply passed through. And up here we should be getting 5.02. It's exactly what we should be getting. And the positive 5's on the pink. Yep, so it appears to be wired up correctly. Right, so we'll put our cable restraints back on. Now, we can use this metalwork to hold the board, but there's nothing really to hold the metalwork in, which is a bit of a problem. It's sort of that's actually kind of interesting. That must have gone much further in. Must have gone in here somewhere. Because otherwise this lid wouldn't have gone on. So we've got it back together. Next thing I suppose is to see if it works. I mean, we know it works. It puts voltages out, but yeah, plug it into the 64 and see if it works. Okay, so I've got the 64 disassembled and on the bench because, yeah, I get a black screen when I power it on. So looks like we've got a bit of troubleshooting to do. And hopefully it's nothing too serious because I don't really have a lot of Commodore 64 parts kicking around. So if it's one of the more custom chips, then yeah, I'm going to have to go shopping to find one. So this is the Commodore 64E shortboard, I believe, which I can't say I've seen a whole lot of these, you know, watching videos of other people's, like, you know, online. I haven't seen a whole lot of these boards around. I'm sure they're quite common, but, you know, the YouTube channels I watch, they just don't seem to have them. But anyway, the first thing, we'll plug some power into it and see what happens. I do get power to the LED. I haven't got the LED plugged in, but I can't remember which pins it is, but it mustn't be those two. Oh, if I turn the power switch on. 3.56 sounds a little bit, oh, I suppose it is driving a LED though, so it's probably through a dropper resistor. But just have a look across. So that's obviously the 12 volt supply there. And there's likely going to be power on this switch, but exactly which. Only 3.5 volts there, that sounds a little low. .3 there, even that sounds a little low. My power supply was putting out appropriate voltages before. I wonder if my power supply just can't deliver a load. Let's plug in. Come on. Right. Okay, so we will solder just a load resistor across the power supply, just so we've got a bit of a load. Negative. Actually, it's the other way around. Not that it matters for what I'm doing, but anyway. So 4 volts, that's just a shade on the low side. Now, the design, which is sort of like a reference design that I was using, doesn't have any bulk storage capacitors, which seemed a little bit odd. I wonder if that's our problem, whether the input to the regulator is dropping off between cycles. Let's just hook the oscilloscope up and have a look. Pain in the ass. Right, so that seems to be our problem. Our output signal's taken a haircut. Well, not so much taking a haircut, but sagging between main cycles. So, let's see. Yeah, look at that. You put a storage capacitor on the input side and it flattens that right off. Take the capacitor away and there it goes to crap again. So we definitely need a capacitor on the input side of the rectifier. Now the previous Commodore power supply had a 2500 microfarad capacitor in that location. This one I was just playing with here is just it's 1,000 microfarads. Or I could go bigger. This one here, 2,200. Of course, there's nowhere on the board to put this, so I'm going to have to cobble it in, whatever I do. So I reckon if I take that little hard to see 56 microfarad cap out of there, I'll take that out. Hold a bit. The spacing on the legs in this is going to be a little bit wide, but we will make do. We will just angle them back together as best we can. Probably about as good as we're going to get. Right, and now we've got a much bigger cap in there. We'll sit it back together, see what it does. I'll just take my test back in. Powered up. And a nice 5.01 volts. So let's plug the oscilloscope in again. There we go. Now we're getting a nice flat 5 volts with a load resistor on it. So hopefully we're now going to be okay. So there we go. We got there in the end. A working Commodore 64C behind me. A bit of a false start with the power supply. Yeah, I should have realised that I was going to need a storage capacitor in the power supply. I mean, it's pretty basic stuff. I don't know why the reference design I was working off didn't have it, but there you go. But yeah, that's working. So yeah, we'll see what else we can make the 64 do in coming videos, I suppose. I don't want to do too many Commodore 64 videos because they've sort of been done to death on YouTube, but I do have a few in the pipeline. I've got a couple of 1541 disk drives to look at, and a couple of other bits and pieces in that same vein. So yeah, we'll see where it leads. But yeah, until then, I'll see you next time. Cheers.